Okay, tree diagrams. What is a tree diagram? Well, it's a way of showing possibilities of two or more events. And simple diagrams we use to calculate probabilities of two or more events. It's basically you've got a left and a right arm. Imagine you can either use one or the other. For example, a fair coin is flipped or it's spun twice. Now, I've chosen this very easy example first of all, just to get an idea of why we use one and what we can use one for. So the first time it's actually spun, I can either go one way or the other. You can either have one outcome, which is heads, or the other outcome, which is tails. But what if I decided to flip it again the second time? Well, if I got a heads the first time, I could get a heads the second time, or I could get a tails. And if the first time I spun it I got a tails, the second time I spin the coin I could get a heads or a tails. Now this is my tree diagram. Now each branch is the actual overall outcomes. Now I can start doing some calculating. If I look at the end here, H and H, what that basically is, if I got a H the first time, a head, I got a head the second time. These are my outcomes. A head followed by a tail followed by a head, and a tail followed by a tail. Now all this is, I've got a half a chance of getting a head and half a chance of getting a tail. But what you need to look at is each branch, if you add up, if you loop down, you add up, each branch has to add up to 1, because all probabilities add up to 1. So when you're looking at a tree diagram, everything should add up, going down should equal 1. Again, equaling 1, and 1 again. Now, if we were looking at what's the probability of getting a head and getting another head, then as we look along the tree diagram, we multiply, because one event doesn't affect the other. So a probability of a H and a H is a half times a half, which is a quarter. And we can do this all the way along. Probability of a head and a tail, half times a half, and so on. And what we need to notice again, if we add up a quarter, a quarter, a quarter, and a quarter, all these outcomes should equal 1. Now, next question. Probability of at least one head. At least one head. Now, where are the probabilities? Where is the outcomes at least one head? There's at least one there. There's at least one there. There's at least one there. Nothing there at all. So what is a probability? It's that one. Should be that one. That one. And not the bottom one. Okay? Now another example. 10 coloured beads in a bag. 3 red, 2 blue, 5 green. 1 is taken. The colours noted and it's returned. That's important. It's returned to the bag. So let's set our tree diagram up. There's 3 possible colours. A red, blue, and a green. The second time, if I pull out a red, well, the second time I could also pull out a red, a blue, and a green. If I pull out a blue first time, I get a red, a blue, and a green. And again, if I get a green the first time, I could also get a red, a blue, and a green on my second time. In the exam, if you only get this far, you're going to gain marks, even if you don't finish the full question. Again, all I'm doing, I'm assigning my outcomes. A red followed by a red followed by a blue, and even if you don't need these in your actual answer, if you only need 1 or 2 of them, there's nothing wrong with finishing it all off. It'll help you. And what we need to remember is, whatever one's taken is returned to the bag. Then a second one is taken. And they're all independent events, like the last one was, because one doesn't affect the other. Now, assign our probabilities. Now, it did actually say to us that there was 10 in total. There's 3, a 2, and a 5. Now, all I've done here is change it to decimals rather than leave it as fractions. I could have left it as a fraction, 3 over 10, 2 over 10, and 5 over 10. And all I've done is assign me probabilities. And all I've done here is worked out the probabilities. These must add up to a whole one, 0.3 plus 0.2 is 0.5. 0.5 plus 0.5 equals 1. And going across, we multiply. So going down, we add. Going across, we multiply. And again, they all should add up to 1.